Okay, hello, ladies and gentlemen. It's Mr. Kaya talking here. And so we're going to go through the first 5 problems from week 1. Okay? This week involves area, volume, and density. So maybe for some of you haven't seen this in a while, so this would be a good refresher for you. Because these are all regions problems. And there's a ton of them. There's always a bunch of these types of problems on your regions. Okay? So anyway, hopefully that just didn't make you sick. Scrolling up and down. So, regardless, all right, here is the triangle I included on there for you. All right, MDV, DMV, however you want to try to remember it. Just always remember that density equals mass divided by volume. Okay, so if you try to memorize that, then you should be able to try to memorize what this triangle looks like. So if you want to kind of derive it in case it doesn't always look familiar. Anyway, so here's number 1. So a fish tank in the shape of a rectangular prism has dimensions of 14 inches, 16 inches, and 10 inches. The tank contains 1,680 cubic inches of water. What percent of the fish tank is empty? All right, that's a key part which we'll play in at the end here. Okay, but the first thing we need to find is, all right, what is the volume of this rectangular prism? All right, so let me draw a nice picture here for you. See if I can do it. Not too shabby. Okay, so there's our rectangular prism. All right, and so let me put some dimensions on there. Now they're not really specific. Okay, but the area, I'm sorry, not the area, the volume of a rectangular prism, right, is length times width times height. Okay, and now multiplication is commutative, so it really doesn't matter what order you multiply all these numbers in, but it's important that you multiply all 4 of these numbers. Okay, so right now, I'm just zooming in here so you guys can see a little better. All right, we're going to look for the volume. So it's 14 times 16 times 10. And you get 2,240, what is this in inches? Inches cubed. Right, so that's the area just by multiplying, or not the area, the volume, just by multiplying all 3 of those together. Excuse me. All right, and so what the problem here says is the tank contains, let's go back here, the tank contains 1,680 cubic inches of water, and it wants to know what percent of the fish tank is empty. So first, we need to find out how much of the tank is actually full. Okay, so think about it like this. Let's say you have a test, which is out of 100 points. And you scored a 75. Well, your score is 75 just because 75 divided by 100 is 0.75 or 75%. Okay? And so that is how you find percentages. Okay, just a brief introduction there. So regardless, all right, going back to this problem, this is our total amount of volume, okay, which is 2,240 cubic inches. And right now they told us the tank is 1,680 cubic inches. So by putting this over the total amount, that will give us the percentage of how much water is in the tank. And how about that? 75%. Like I knew it was coming. So, so that is how much water is in the tank. Now don't forget the problem is asking how much of the tank is empty. So if the tank is 75% full, then that means the fish tank is 25% empty. Okay, so watch those tricky problems here. Because guess what they put? They put 75 on there. All right. In hopes that you would go for it. But just remember, just be careful when reading these problems because they're not so straightforward sometimes, right? They throw little tricks like that in there. Okay? All right. Let's look at number 2. So as shown in the diagram below, a rectangular pyramid has a square base whose side measures 6 inches. If the altitude of the pyramid measures 12 inches, its volume in cubic inches is one of these 4 options. All right, so they tell us a regular pyramid, okay, has a square base whose side measures 6 inches. All right, so a key word here is square. All right, so that means the base of this rectangular pyramid looks like this. All right, which means this is 6 inches, which means this is 6 inches, and so on and so forth, okay? So that's just the properties of a square, right? All sides are the same. In order to find the area of a square, is length times width. Okay, so keep that in mind. Now, when finding the volume, because that's what we're looking for, we're not looking for area, we're looking for volume. This is a 3D shape. Right? The volume of a regular pyramid okay, 1/3 big base times the height. Okay? And let me rewrite this in a different color here because this one is important. The big B. And what the big B stands for is the area of the base. So what you want to think about is what the base looks like. In this case, they told us it is a square. And how do you find the area of a square? Length times width, which in this case is 6 times 6, which is 36. Okay, so the area of our big B is 36. Now, let's plug everything in. All right, so they give us the height. All right, that's what the altitude stands for. Okay, so the altitude is 12 inches. So let's just fill in the blanks here. I get a different color. Scroll over here. So volume equals 1/3 the area of our base, which is 36, okay, times our height, which in this case is our altitude, which is 12 inches. Just plug that into your calculator. And you get 144 inches cubed. Okay, make sure you include your units. Otherwise the Regents will mark you wrong. Alright, and as you can see, do we see that answer down here? Sure do. Okay, and there we go. And so that's the answer to number 2. And any questions on these guys, feel free to email me if you need further instruction on these. Okay. Number 3. Whoops, come on, scroll in. Thank you. All right, so the diameter of a basketball is approximately 9.5 inches, and the diameter of a tennis ball is approximately 2.5 inches. The volume of the basketball is about how many times greater than the volume of the tennis ball? So, let's talk about these two properties right here. Okay, so we want to find the volume of each of these, and they give us the diameter. So if you don't remember what the area, or not the area, why do I keep saying area? The volume of a sphere is, right? This formula is given to you on your reference table. So if you don't remember these, you can either look them up on my YouTube channel. You can look them up, if you have internet access. Obviously, you can just type in, volume of a sphere, and all that information should pop right up. And I also should have sent you a reference table. So anyway, use your resources, guys, all right? If you don't, and you just need me, hey, Mr. Kaya, could you send me the reference table? I could resend it to you. But anyway, so here's the volume of a sphere. It is 4/3 pi r cubed. Okay? It's a bit, it's not as simplistic as our other area formulas, but it's not too heavy. Okay? You just got to remember that 4/3 pi r cubed, and just think cubed, because we are dealing with a 3-dimensional shape now. All right? We're not talking about the area of a circle. We're talking about the volume of a circle. All right, in this case, the volume of a basketball. So they give us the diameter. If you remember, the diameter is twice the radius. Okay? Which means in order to find the radius, we have to divide the diameter by 2. Okay? So, cut that out here. All right, so our basketball has a diameter of 9.5. 0.5 divided by 2. And you get 4.75 inches. Okay, so that is the radius of our basketball. Whoops. Whatever. Okay. So, the tennis ball has a diameter of 2.5 inches. So take 2.5, divide that by 2. And you get 1.25 inches. And so that is the radius of our tennis ball. And all we have to do is just plug all that information in, okay? So right now we're just looking for the volume. We're still not answering this question yet, right? But we'll get there. Okay, so let's start with the basketball. So the volume of the basketball, I'll just plug it in down here. So volume is equal to 4/3, scroll in. Right. Oops, forgot the pi. Pi and 4.75 cubed. And then the tennis ball, its volume is 4/3 pi 1.25 cubed. All right. Give you a second to come up with those answers. So for the basketball, should have gotten 448.9205,002. Okay? Now I'm not rounding up yet. I will round at the end. Okay? Right now I'm just leaving it as is because I want to get the most accurate answer I can. All right. And so this one down here for the tennis ball, you should have gotten 8.18. 0.0869. All right, so that, oops, what did I forget? I've forgotten my units. This is inches cubed, and this is inches cubed. Ooh, make that look like a cubed here, not inches times 3, inches cubed. Okay, so we haven't quite answered the question yet, but we did find the volume of each of these. Now the question is asking, okay, the volume of the basketball is about how many times greater than the volume of the tennis ball. Okay, so it wants to know how many times, how much larger is the volume of the basketball in comparison to the volume of the tennis ball. In order to find that, what we're really looking for is how many times the volume of our tennis ball divides into the volume of our basketball. All right, so think about it like that. In order to find out how many times our basketball is greater than ours, we need to divide the volume of the tennis ball into the volume of the basketball. So let me get a different color here. So 448.9205002 divided by 8.181230869. Take me a second to plug all that in. 502 divided by 8.181230869. Right? And you should get an answer of 54.87199 repeating. Okay? So think about it like this. The volume of our tennis ball times this number here equals this number right there. Okay, so our basketball, its volume is 54.8719 times greater than the volume of our tennis ball, right? That's how many times the volume of our tennis ball divides into the volume of our basketball. And so it's about how many times, okay? So if you look at our answers, right, definitely not these. Oops, crossed out the wrong one. Hey-oh. All right, certainly not 4, certainly not 65. It has to be 55. Okay? Alrighty. Let you guys get a second to soak that one in. Alright, moving on. So a designer needs to create perfectly circular necklaces. The necklaces each need to have a radius of 10 centimeters. What is the largest number of necklaces that can be made from 1,000 centimeters of wire? All right. So let me get us a perfectly circular necklace. Look at that. Perfectly circular. Not so bad, if I do say so myself. So it says it has a radius. We need it each of these to have a radius, so I'm going to try to put that as center as I can. Okay, of 10 centimeters. It says, what is the largest number of necklaces that can be made from 1,000 centimeters of wire? Now, we are not trying to find, what we are not trying to find is the area of this circle, okay? Because that wouldn't make sense. How would you put the necklace on if your necklace covers the whole center, okay? We're not trying to find the area of this circle in this particular problem, okay? We're trying to find the circumference, okay? We want to know what is the distance around this necklace here. What is its measure, okay? How much wire does this designer need? okay? So that's what we're looking for. So it's important to remember these formulas, okay? So pi r squared, okay, which again is on your reference table. Okay, this is the area of a circle. We're looking for the circumference. And the circumference has a couple different representations, okay? It's either pi r times 2, okay? Or, if you remember the radius is just twice the diameter, pi times the diameter. So, in this case, they give us the radius, so we're going to use this equation up here. All right? So in order to find the circumference, okay, we are going to go pi times 10 times 2. And you get 20 pi, which is approximately 62.83185307. Okay? And so they give us 1,000 centimeters. So think about it like that problem we just did. We want to determine how many, necklaces can we get if our circumference needs to be this right here. So how many times does 62 go into 1,000? Okay, we want to know if we divide 1,000 by 62, that will give us how many necklaces we can get. All right, so we're dividing 1,000 by this answer down here. I'm trying to keep it as accurate as possible, so I'm using all of my digits, but I will round at the end. So 1,000 divided by that number, and you get, change the color here, 15.9155 necklaces. Okay, so what that is saying, right? When our necklaces need to be this long, okay, in order to use up this much wire, okay, we can make up to about this many necklaces. Okay, but we can't make 0.915 of a necklace, right? That doesn't make sense, so we have to round, and we want to round down because we didn't quite make it to 16. So 16 is out, and 15 is our answer. Okay? Hopefully that made sense to you guys. Like I said, any questions, any concerns, feel free to email me. All right, so next one's kind of interesting. Now, we've done density. We haven't done a population density, okay? So I don't think this one is too much beyond you guys. We have dealt with density before. This one just breaks it down on a little different level, okay? But the process is still very similar. So let's talk about it. So during an experiment, okay? And also, let me draw the triangle here. See if I can get a nice triangle going. Nice. Whoops. Okay. How about that? MDV. Okay. So, during an experiment, the same type of a bacteria is grown in 2 petri dishes. Petri dish A has a diameter of 51 millimeters and has approximately 40,000 bacteria after 1 hour. Petri dish B has a diameter of 75 millimeters and has approximately 72,000 bacteria after 1 hour. And wants to determine and state which petri dish has the greatest population density of bacteria at the end of the first hour. Okay, so the first thing we want to do, all right, is we want to find the area of each of these circles, okay? Now, we're not trying to find the volume, okay, because this isn't a three-dimensional shape. We're trying to find the area. So, in order to find the area of this circle, okay, we need to take this diameter, and we need to divide it by 2. Okay, so 51 divided by 2 is 25.5. I got to do the same thing with this one down here because we're looking for the, oops, not 2. Hello. Not 5, but 2. Okay, because we need the radius. We want this measure right here. Okay, in order to find the area of our circle. All right, so divide that one by 2. 75 divided by 2. Use it in there. And you get 37.5. Okay, so this is our radii. Okay, our radius for each circle. So if you don't remember what the area of a circle is, it's pi r squared. So in this case, they give us the area, or they give us the radius, 25.5 squared. We get an answer. Give me just a second. And we get 2042.820623. And what is this? Millimeters squared. All right. Let me move that up a little bit. So, oh crap. There we go. All right. So that is the area of that circle. So in order to find the area of this circle, again, we're using the same process. Pi r squared. In this case, it's 37.5. Okie doke. Millimeters squared. Okay, don't forget your units. So that is the area of those two circles. All right, so think about it like this. So let's go back to our equation over here. Find the density. It's mass divided by volume. Okay? Well, we don't really have a volume here, but what we do have is we do have the area. Okay? What else they've given us is you want to think about it kind of like the mass, all right? Kind of like a mass of people, if you will. All right, so our mass of people, or, oh, I'm sorry, sometimes they have population. In this case, it's bacteria, but in this one, our mass is, in this case, 72,000 bacteria. All right, so what we're trying to find is how much bacteria per square millimeter. Right, that is our density. That is what we are looking for. So anytime you run into a population density problem, this is how you solve it. You got to find the area of the two-dimensional shape, and you want to divide the mass, which in this case is bacteria, by your area. All right, so in this case, we're going to take the 72,000, because that is our mass, and we're going to divide that by 4417.864669. And we get a density. Oh, I'm sorry. And this is why it's important to put your units on here. So this is bacteria. And this is millimeters squared. So our density, okay, so our density should be 16.29746617. We're going to round. We're going to round down because we can't have 0.29 of a bacteria. You either have a bacteria or you don't. Excuse me. And so our density is 16 bacteria per millimeter squared. And that is our population density. All right, so let's scroll over to this problem over here. Okay, we're going to use the same process. Okay, so our density is mass divided by volume. In this case, our mass is the amount of people, or I'm sorry, bacteria. And our volume, it's not a three-dimensional shape, it's two-dimensional, so it's really our area, is 2042.820623. And this is bacteria. And this is millimeters squared. So our density is 19. I'm just going to round right now. Okay, I should say 19.5. Round to 19.6. I want to say, and we can't have 0.6 of bacteria, so it's 19 bacteria per millimeter squared. All right, and so now the question's asking, all right, determine and state which Petri dish has the greatest population density of the bacteria at the end of the first hour. And so as you can see, 19 is greater than 16. So we say Petri dish, uno, or one. Okay, so we haven't really seen a population density problem yet, but it's very similar. And think about it as a sense of like, this is your mass, right? Because this is two-dimensional shape. All right, and then our volume is really not a volume; it's an area, and so that is how you want to think about those problems. Okay, so anyway, I'm going to upload this and keep checking for videos. I will keep you posted.